In this exercise, we are going to analyze the attribute response of the bright spot amplitude anomaly by cross-plotting the isofrequency attributes. Let's begin and launch the attribute set 3D window. You can do this either by clicking on the corresponding icon or go to menu Analysis, Attributes 3D. Choose Spectral Decomposition attribute from the list of all attributes. We are going to use the time gate of -12 to 12 milliseconds, and we are going to define 3 attributes. The first one is for 24 Hz with a step of 4 Hz. Let's give it a name such that it reflects the parameters we used. Click Add as New. In a similar way, we are going to define 2 more attributes for 44 Hz. Change the name and click Add as New, and 64 Hz. Change the name, Add as New. Now you can either save on close, this way the attribute set will be saved in case you want to retrieve it later. I will uncheck the Save on Close checkbox and close the attribute set window. Now we are going to apply these 3 attributes on a color blended horizon. For this, let's add a color blended horizon to the 3D scene. Click on the 3D horizon item in the OpendTect tree, Add Color Blended. We'll select the Demo 6 horizon for this exercise. When adding a color blended horizon in OpendTect, it automatically pops up a window where you can select attributes for red, green, blue and alpha channels in one go. Let's go ahead and select the attributes that we just defined. We'll pick 24 Hz for the red channel, 44 Hz for the green channel, and 64 Hz for the blue channel. Alpha channel we will keep empty and click OK to start the processing. Depending on how powerful your computer is, it will take about 1 or 2 minutes. Click on the drop-down list for the View icon and select View North Z to observe the result from the top view. Now we are going to create a polygon which we will use later for area subselection in the attribute cross-plotting. For this, click on Polygon item in the tree, New. Type in a name, we will call it Shallow Bright Spot, and press OK. Use left mouse button to outline the polygon. Double-click to close the polygon. Right-click on the polygon name to save it. Now let's begin with our cross-plotting. To launch the cross-plot tool, you can either click on the corresponding icon or go to menu Analysis, Cross-plot Data, Attributes versus Attributes. Make sure the attributes we just created are selected in the list. We'll select our locations by polygon. You can see that the polygon we just created is already selected. Online and cross-line steps we'll set to 1 and 1. We'll keep the time range the same and set the step to 4 milliseconds. We'll use all the positions inside the polygon, and let's set our location filter to the horizon on which we displayed the spectral decomposition attributes. Demo 6. By default, extraction happens on the horizon, but you can also extract attributes around a horizon. In this case, you will need to specify a time window around this horizon, with the extra Z parameter and Z step. Or you can also extract attributes between two horizons. Now click OK in both windows to proceed. Now we are going to create a crossplot of two attributes for 24 Hz and 44 Hz. In the popped-up spreadsheet, find and select the attribute of 24 Hz to be displayed along x-axis by clicking first on the column and then on the Set Data for X icon. In a similar way, click on the 44 Hz column to assign it to the y-axis. Optionally, you can add more attributes to the y-axis by selecting a column and pressing Y+ icon, or remove the selection by pressing Unselect icon, Y-. To have a better feel of the data's behavior, let's toggle on the density plot icon. You can see two different regions on this crossplot: the regions with high amplitudes and the region with lower amplitudes. We are going to select both regions and display them on the horizon. To select a region, use the Selection tool. Click on it once to change to the freehand drawing mode and outline one of the regions. Now click Show Points in 3D icon. We are going to display all selected points in the 3D scene. And now let's switch to the 3D scene. Right-click on the green colored points to save it as a point set. Let's call it High Amplitudes and click OK to save. Let's go back to the crossplot window and click on the Clear All Selections icon and draw another polygon around lower amplitudes. And again, click Show Points in 3D. As you can see, now a different area is highlighted. Let's save this one as well by right-clicking on it. Save as point set. This one corresponds to the lower amplitudes. I will go back to the crossplot window to close it and display the point sets that we just saved. Note that the separation of frequency highlights two different regions of the bright spot. In this exercise, you saw how the crossplot tool has helped us to identify the changes in the gas pocket that are possibly due to differences in saturation of thicknesses. Optionally, we can repeat the same exercise to crossplot all three attributes together: spectral decomposition of 24 Hz, 44 Hz and 64 Hz. This concludes the cross-plotting workflow for attributes.